Hi there. Let me take a few minutes and talk about the solution and the rubric for this number 6 investigative task, where you have two approaches to answering a question. One involves a simple random sample and the other involves a stratified sample, and you're looking at the differences in the variability between those. So first of all, for part A, you are asked specifically to describe a method to select a simple random sample, the way that Peter is doing. So understand, it is not enough to say, use a random number generator or randomly pick names out of a hat. That is not enough here. This is a question where you would be expected to take a good 20 to 25 minutes to answer it. So you need to be more specific than that. And specifically, the rubric says you have to provide a procedure that will obtain a simple random sample, and you have to give enough information so that knowledgeable statisticians would be able to actually implement the exact method that you are giving. So here, more is better. So, for instance, most students tend to do this with a random number generator. So every name should be assigned a unique number, 1 to 2000. So using a random number generator, so you have to give a specific method, the subjects corresponding to the names matching the first 100 numbers selected becomes Peter's sample. So understand, I'm saying that the subjects, which are the people, those are going into your sample, that correspond to the names because the names were what were numbered. The first 100 of those numbers will explain which subjects actually go into Peter's sample. And this is very important. Without this, your answer is partially correct. This is very important. You have to describe that if you are using a random number generator, if a number is repeated, that number should be ignored and a new number should be generated. So you do have to deal with the issue of repeats. The hat method is probably the simplest way to earn full credit. So you could take all 2,000 names, write them on equally sized slips of paper, put them in a hat. But this part is very important. You have to shake the hat. You have to do something to a hat to suggest that now they are in random order, so that means you select them. There's no reason why one slip of paper would be more likely than another. So, or any group of 100 would be any more likely than another group of 100. So Peter should select 100 slips of paper, and the subjects whose names correspond to those 100 slips of paper become Peter's sample. Because the sample is not the numbers, the sample is made up of the subjects. So a best answer will use that word subjects, because it's not the numbers that become the sample, it's the subjects that are put into and become the sample. So part B is an incredibly simple question, but an answer, simply 0.413 without supporting work, is incorrect. And notice this is just a straight use of one of the formulas on your study guide. What am I saying? One of the formulas on the formula sheet. So on the second page of the formula sheet, here is the information about the sampling distribution of a sample mean. And Peter is calculating a sample mean for the number of sodas that are consumed in this time period. So you can simply use the standard deviation provided, the 4.13, and divide by the square root of the 100. The formula is right there on the formula sheet, but you have to show both the work and give that final answer. So that's part B. Part C of the question then, there are 3 things that are required for an essentially correct answer. And I really like this question because it's a good reminder at this point of what we combine. Guys, if you want to think about Raina's estimator, her estimator for the standard deviation, understand she used a stratified sample, so we have to combine the female estimate and the male estimate. So understand, we don't add standard deviations, we add variances. So the 1.8 over the square root of the 60, that gives me the information, the standard deviation for the females. The 2.22 divided by the square root of the 40, that gives me the standard deviation for the males. But then you have to square them in order to turn them into variances. And notice, because this is a stratified sample, 60% of the sample is female, 40% of the sample is male. So I need to weight these variances by the 60% and the 40%. But be careful, the variances are squared quantities, so the weights also have to be squared. Of course, we're assuming these groups are independent of one another so that we can actually add the variances, and then you can finally take the square root in order to get your estimate of approximately 0.197. So what's required for an essentially correct answer? You have to be showing that you're combining variances. Showing your work is really important here. Those squares show me that we're combining variances. You have to be using the weights, and then you have to recognize that the variability is phrased in terms of sample means. So this is the variability using the same formula that we did in Part B. This is the formula that you need to use to represent the standard deviation, and thus the variance for the sample mean for the women and for the sample mean for the men. All three of those components are required in order to get an essentially correct answer here. A partially correct answer has a formula or work that represents at least two of those three components. Anything less than that would be an incorrect answer. And so finally then, the last part of the question, you have to analyze the dot plots. And there are two portions of this answer that are required. So first of all, you have to be discussing less variability in the responses for each gender in comparison with Peter's combined responses. So the dot plots suggest that the number of soft drinks consumed per week by females and the number by males both have less variability individually than Peter's distribution. So I have made a comparison to Peter's distribution in terms of the variability. That's very important. That's the first component. But then the second component is you actually have to take what you're seeing in those dot plots and you have to link it now to the fact that when we combine the smaller variability in both the male and the female strata in Rhina's estimate, when we make that combination, we end up with overall less variability than what we see for Peter's standard deviation. So somehow you have to talk about the fact, and this is difficult, you have to communicate the fact that we are weighting this. So notice, as the work in Part C demonstrates, Rhina's standard deviation is calculated by weighting the two distributions with less variability. Hence, her overall estimated standard deviation should be smaller than Peter's. So it's very important to link together that combination with the fact that Rhina's estimator is going to have less variability. You have to link the calculation back to the smaller amounts of variability in the individual samples from the males and the females. So that weighting is important. So that portion D was by far and away the hardest part of this question in order to get an essentially correct answer here. So, but there are, on the flip side then, some really essentially quite simple things here. For instance, Part B, this is just a straight application of the formula right there. And literally, that's 1 point. If you showed the work and did this simple calculation, there's one of the 4 points. There's one of the 4 points. And as long as you're specific and take the time, remember, this is a question that should take you 20 to 25 minutes. That means your answer to Part A should include some detail. You should be specific here. Explain how the numbers are being assigned, how that representation goes back to subjects. Make sure that you're ignoring repeats. Those subjects then become part of your sample. The unique numbers or identifiers are linked to those subjects. Just being careful and purposeful about how you write that answer and being specific. That's one of the best ways to get you partial credit in Part A. Hope this has been helpful.